Good afternoon, Professor. This is my personal timetable. I attend research group meeting on every Monday, and I attend biomedical physics offline class that is on every Friday, and studies electrolysis and telecommunication trends. And I also studied about big data and tomorrow I have to submit big data assignment as well. And side by side, I'm studying my research work also. Research on radiometer for medical sensing application using different reference noise source. So what I have studied in this week, and I'm going to present today. This is the paper title: Total Power Radiometer for Medical Sensor Application Using Match and Mismatch Noise Source. This was the paper title. It was published in 2017. Publisher name was Sensor. And in this paper, the total radiometer have used non-invasively measure the temperature of human body. Microradiometer has proposed medical application using match and mismatch registered at room temperature, and they had used 3 gigahertz radiometer contain at antenna and amplify of the noise power, and it converts the noise power to voltage via detector. SP3 switch has been used, which is placed between antenna and receiver, and process data such as detector voltage output and physical temperature of the reference noise source. And two reference noise source, hot and cold, are proposed using match and mismatch registered at room temperature. And the next is the introduction part. In this non-invasive thermal measurement of human body to measure core body temperature monitoring, thermal imaging of breast cancer, Dick radiometer has used traditional technique. As you can see in this figure, antenna, LNA and BF booster noise together told as a front end. And it is advantage of this Dick radiometer: it is inexpensive, small size, front end edge of radiometer and single reference noise source. Drawback: it has one load calibration which is very inaccurate. Because of that, it assumes that noise figure of radiometer does not change, and it has some input temperature ranges which operate under 246 Kelvin to 316 Kelvin, and performance of imbalance among the port SP3T switch, and it can also cause error in temperature offset voltage of radiometer output voltage. And next is the design of radiometer with two reference noise source, low noise and high gain receiver, amplify input noise power generated by an object. P out of the receiver, P has a equation: gain receiver in bracket T in temperature input plus temperature receiver, whereas T in is a input noise temperature which is equivalent to temperature of receiver, and K is a Boltzmann's constant. It has a value of 1.38 into 10 raised to 23 JK. Band: it has a bandwidth of receiver. Gain receiver, G denotes as a gain receiver gain also you can call. I'm just describing this radiometer, uh, what all the things has been used, what component has been used. First of all, it is two reference noise source, direct conversion receiver is there, LN BPF is there, voltage output is proportional to input, and DAQ is used for uh, DAQ, it's data equation board, for reading the output of that voltage, and then it processed by the personal computer. And after that, uh, after that, reference 1 and reference 2, which is reference 1 is cold and reference 2 is hot noise source, and sp3 switch is uh, there, uh, in as you can see in this. And AOB is there, that is analog output, which generates a switch control. And we had two sensor 1 and sensor 2. Sensor 1, um, it measure physical temperature of two reference noise source, which targets the T, and component in the receiver mounted on single aluminium. Physical temperature of two reference load is TR, antenna TPA, and transmission line TPL. These all are in equal positions. In this two reference noise source, it is a subtopic in this paper. It has the two load calibration needed for different noise temperature. Cold and hot noise source are simply implemented using mismatch, and where you can we have certain equations. Temperature reference, that is equal to impedance, uh, Z0 is the impedance, and minus receiver reference upon impedance uh, plus you can say receiver reference. And based on this relation, hot and cold fabricated, uh, 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 sorry for the this sorry for this disturbance. And first reference value is 22 current, and second reference value is 50 current. When you calculate temperature reference 246 Kelvin into Celsius, that gives to 27.15 Celsius, and 290 Kelvins gives the figure 16.85 Celsius. And as I said before, TR is equal to T reference 2, so the value of both becomes same, so it has 290 Kelvin. And when you convert in Celsius, it becomes same as 16.856. And as I said, temperature TR is measured by temperature sensor 1. In this we have another subtopic. Sorry. In this we have another subtopic, that is logarithmic detector. In this we have use a square law detector with high sensitive, and this radiometer calibration is based on linear relation between power and voltage. As you can see in this graph also, power is in line y-axis, and it line x-axis. This is y-axis and this is x-axis. and the input noise temperature of normal human body is 307 and ranges between 311 K, which is much higher than the hot noise at source at a room temperature. And V out, the measured output voltage is voltage as is measured as a single generator power meter and voltage meter, and input power increased from minus 40 to minus 30 dBm at 3 gigahertz. And again this measurement was repeated 4 times to increase the modeling accuracy. The least mean square method was applied to fit this measurement data. In 16, resulting gamma is 0.0308 and beta is 2.5301. And as you can see, this blue line is a linear fitting, blue dotted line is a linear fitting line, and red denotes a log fitting, and the dotted circular dotted, you can see it's a measured data line. And to measure there are to obtain the, two measured V output values, hot hot and cold. uh, it can be expected a linearly fitted model that the error will keep increasing, and the target increase the higher than the hot surface, this reference to. And last is the temperature measurement setup. Uh, in this I'm going to explain this figure. In this we have a measuring temperature heated water bath is a styrofoam, and a shielding container aluminum. As you can see in this figure also, it's a orange color something. And it has and water, uh, it's about 9.5 centimeter, above 9.5 centimeter, above than 20 centimeter, there is a antenna holder. And uh, uh, then after, there is a temperature sensor, and sensor 1, sorry, sensor 2 it is, and which is connected to a DAQ for reading this temperature. And then this DAQ, as I said in this design of radiometer slide, DAQ is connected with the personal computer. And and uh, uh, um, uh, sorry, water bath styrofoam dielectric constant has a 1.03 value. And uh, its detector voltage is average every 25 samples and used to determine the receiver gain. Thank you for this presentation. Thank you for the day.